Hello everyone, my name is Harsha. I'm here to discuss about random network coding for multimedia delivery services in LTE and LTE Advanced. LTE is developed by the third generation partnership project, which is all famously known as 3GPP. So basically, LTE was introduced to increase the capacity and speed of wireless data networks using the new digital signal processing techniques and modulations. The main features LTE is known for providing a high throughput, low latency, simple architecture, and low operation costs. So, uh, let's first discuss about HRQ protocol. HRQ protocol, also known as Hybrid Automatic Repeat Request Protocol, it is a mix of automatic repeat request and the forward error correction. HRQ is done in combination between the medium access control layer and the physical layer of the LTE protocol stack. The physical layer is responsible for the retention and recombination, and the MAC layer is responsible for the management and signaling. In order to ensure the reliability of data transmission in LTE, MAC HIRQ has been developed and which is being used currently for the multimedia delivery. HIRQ can not only optimize the security of the transmission, but it also increases the throughput of the system. HIRQ is developed from the ARQ mechanism, and it is a combination of HIRQ and ARQ which deal with the errors that they come across while transmission. In the following slides, I am also going to discuss the operational methodology and the layers of operation. So what are the advantages of HIRQ? HIRQ has solved some of the problems plaguing the previous generation models like 3G. HIRQ has helped in increasing the amount of security to the packets being transferred. It also takes care of the packets. It makes sure that they reach the destination by retransmitting whenever needed. So even the throughput is also increased and the amount of compression with respect to the bits increased, thereby ensuring a higher data rate. Even though HIRQ is being used, it has a few drawbacks which led to the introduction of RNC protocol. So let's discuss the drawbacks of the HIRQ protocol. HIRQ suffers from the issues such as high error rate, limited bandwidth resources, and it does not alter the characteristics of LTE as LTE is oblivious to the traffic buildup around it. So, as said earlier, RNC has been proposed to counter these issues HIRQ has been facing. So, the project I did, it deals with implementing the RNC protocol and also comparing the HIRQ and RNC by seeing its SINR ratio and also the throughput to prove that RNC is better suited for transmitting the multimedia packets. RNC protocol, also known as Random Network Coding Protocol, is a replacement for HIRQ protocol. Due to the disadvantages found with the HIRQ protocol, RNC has been developed. So RNC is also carried out in the combination between MAC and the PHY layers or the physical layers of the LTE protocol stack, similar to the HIRQ protocol. But RNC protocol also includes a special layer in the MAC layer, which is also called MAC sublayer. This sublayer is the main difference between the two protocols. With the help of this sublayer, RNC provides a new set of opportunities for content awareness, better resource allocation, and unequal error protection, which are essential for efficient wireless multimedia delivery in LTE. So this figure shows the lifetime of a packet in the MAC HIRQ protocol and MAC RNC protocol. Though the difference occurs in the MAC RNC sublayer, which provides the features such as content awareness, resource allocation, and unequal protection for the packets being transmitted. So the objective of this project is to prove that or to show that the LTE is more traffic conscious because of the use of RNC protocol, and to also show the advantages RNC has over HARQ. Few advantages to say lesser data overhead, reduced error probability, and increased throughput. Another advantage of RNC is it uses less energy, that is, it uses less resources, which also results in the increase of the throughput. To explain that, consider a packet which has to travel from the source to the destination. It has to travel through a large number of network paths, but in case of RNC, the number of paths for the packet to travel through is reduced. As a result, the energy is conserved because the number of resources which are used are lesser than the HRQ protocol, and also the throughput is increased. To prove that RNC is better than HARQ, first I coded RNC using MATLAB, then I plotted the graphs for SNR and throughput. So for calculating SNR, we would need path loss, shadow loss. So we can say that RNC is better than HRQ by seeing its SINR and throughput. If better the SINR, better the uh, protocol, and better the throughput, better the protocol, and better the efficiency. So this is the virtual network which was created to test the RNC. One is the source and 9 is the destination. And there are various paths available. So SNR is calculated using path loss, the transmission power, the receiver antenna gain, the transmitter antenna gain, and the noise at the user equipment, and the intracell difference, and the shadow loss, and also the wall penetration loss. SNR is mainly affected by these factors. So the SNR is calculated for both the protocols using the LTE archives which are provided in this table. So this is the graph for the shadow loss versus distance. You can see that the shadow loss is more as the distance increases, but it is almost the same for higher distances. Similarly, for the path loss increases as the distance increases. And this is the SNR graph plotted for the HRQ protocol as well as RNC protocol. If you can see that SNR is the red color graph shows the plot for the RNC protocol and the blue color shows for the HRQ protocol. Even with the increase in distance, the slope of HRQ and RNC are same. So RNC has performed better in all the scenarios, even with the increasing distance. So the more the SINR value, less interference to the packets being transmitted. We can also say that the uh, error rate is also low. So the conclusions are MAC RNC is a protocol that is proposed alternative to HARQ. As it was previously mentioned, LT is oblivious to the traffic that is generated around it. But by implementing the RNC, LT is made more traffic conscious, and it leads to the better management of the traffic that has been built up. So as a result of this, even the throughput increases. Another characteristic which differentiates the RNC and HRQ is the low error rate provided by the RNC. Lower the low the error rate and low is the rate of retransmission. The compression of bits is also very high compared to the previous protocols. As a result, the data rate also increases because of the less size of the packets. Unequal error protection is also provided by the MAC RNC sublayer, which also reduces the overhead. Now let's see the simulation of the various mathematical models for calculating the SNR ratio for RNC as well as HRQ protocol. So this is the mathematical model for computing the path loss. So the path loss involves distance, wavelength, and the receiver gain as well as the transmitter gain. And this is the mathematical model for shadow loss. The shadow loss is depends on the distance and also the delta DC value. Similarly, SANR, as we already discussed, SANR is dependent on transmission power, transmitter gain and antenna gain, receiver antenna gain, and the intracell interference, shadow loss, path loss, and the penetration loss. I also calculated the throughput to show RNC has a better throughput than the HARQ protocol. So let's see how RNC performs over HARQ. So initially we calculated the path loss. We can see that the path loss is increases and over the distance, and path loss is same for both RNC as well as HRQ, because path loss usually depends on the transmitter gain. So this is the shadow loss, which is also same for both uh, HRQ and RNC. This is the SINR plot for the HRQ protocol and RNC protocol. We can see that RNC has a better SINR ratio over HARQ. This is the throughput for the RNC protocol as well as HRQ protocol. You can see that the throughput of RNC is higher than throughput of HRQ even with the increase in the number of nodes. So we can say that RNC protocol and is better than HRQ protocol because of the introduction of the MAC RNC sublayer. Thank you.